Welcome back to the channel. Happy to see you all again with a new chapter, that is chapter 2 of ICSE class 10 chemistry. That is your chemical bonding chapter. This chapter forms the basis for your class 11 and class 12. So please observe the videos very carefully and take down the notes also. Let's go to our today's video. Welcome back. To begin with the chapter, that is your chemical bonding, let us discuss about the basics of this chapter. That is, we'll begin with stability of an atom. When will an atom get its stability? What do you mean by stability of an atom? What happens if the atom is stable? We'll discuss the answers for these questions. When will an atom gets this stability? An atom gets its stability when its valence shell is completely filled. What is valence shell? I already told you in my previous videos, valence shell is the outermost shell of an atom. If an atom has s orbital, p orbital, d orbital and f orbital, isn't it? S orbital can accommodate 2 electrons. P orbital can accommodate 6 electrons. D orbital can accommodate 10 electrons. And f orbital can accommodate 14 electrons. If an atom, the outermost shell is p orbital, if it should be p orbital, how many electrons it should have? It should have 6 electrons, which means if the p orbital has 6 electrons, the atom is considered to be completely stable. Isn't it? After p, this like the outermost orbitals are empty. P orbital is the outermost for a particular atom. If that outermost p orbital has 6 electrons, we will call it as a stable atom because the outermost shell is completely filled, isn't it? So, what is this stability? Stability in the sense, if the atom's outermost shell has completely filled electronic configuration, this atom does not react with any other atom. It is highly stable. Yes, so you may ask me, what is reactivity? Yes, reactivity is if an atom has some deficiency, it will find for other electron, like it will find for other atom. It will react with other atom. Take for an example, somebody is scolding me, somebody is criticizing me. When will I react? I will definitely react for them if really I have that deficiency in myself. If I am not having those deficiency, whatever they mention about me, I don't react for whatever they say, isn't it? I'll be highly stable, coolly enjoying, isn't it? That is what is stability. So when will an atom react for the other atom? If it has some deficiency, either it should have like extra electrons, more electrons, or it should have less electrons to attain its octet. Octet in the sense, it should have completely filled configuration, that is 8 electrons in its outermost valence shell. Octet is nothing but 8 electrons, completely filled electrons in its outermost shell. So to attain that octet rule, that completely filled configuration, if it has less electrons, it needs to get that electrons to satisfy that octet rule. If it has more than 8, it has to lose those 2 electrons to attain that octet rule. So that is what determines the stability of an atom, either by losing electron or gaining electron. So which means, if a particular atom either loses or gains electron, we don't call it as a stable atom. That doesn't determine the stability of an atom. This atom is not stable in its original state. Okay, if it has deficiency in either increase of electrons or decrease of electrons, increase or decrease, I mean to say more electrons to attain its octet rule or less electrons to satisfy its octet rule. So that is what is stability of an atom. Hope you all understood. Yes, let's see. Stability. An electron arrangement of atoms. So this stability is determined by the electron arrangement. As I already told you, the filling up of electrons, or I can say electronic configuration. That is, for inert gases, that is your helium, krypton, neon, argon, xenon and radon, all these are noble gases or inert gases. Inert. The word inert means it's highly stable. It's very less reactive. It don't react with anybody. In the sense, when will an atom or an element reacts? When it has some deficiency. Yes, but here for all these inert gases, they are highly stable because their outermost shell is completely filled. Let's see, helium has 2 electrons in its outermost shell. That is, it has only s orbital. S orbital should accommodate 2 electrons. So, helium has 2 electrons in its outermost shell. That is why it is highly stable. Next, krypton, neon, argon, xenon, radon, all these inert gases, all these noble gas elements has 8 electrons in its outermost shell. Of course, that is also full. Just now I said it has to satisfy the octet rule. It's already satisfying that octet rule. That is why these inert gas elements are highly stable. They don't react with any other element so easily, which means they are less reactive. So they have stable electronic configuration. See, look at the diagram. This is helium, this is neon. Helium with electronic atomic number 2. That is, it has 2 electrons. See, this is the nucleus and this is your s orbital. S orbital, 2 electrons are filled in the s orbital only. This is the outermost shell for helium. The outermost shell is filled. This is s orbital. S orbital should have only 2 electrons. So, the s orbital is filled. Next, neon. Neon's atomic number is 10 and its electronic configuration is 1s2, 2s2, 2p, 2p6. So totally 10. So 1s2, this is your 1s, 2 electrons, s orbital is filled. P, this is 1s2, 2s2 and again 2p. If you see, it is 6 electrons. Then next, if you see, so totally outermost also has been completely full. So how many? 1, 2, 3, 4, 5, 6, 7, 8 and 9 and 10. So 10 electrons. Outermost shell, if you see, the 2 s orbital has 2 electrons, which is filled configuration only. So helium, neon and same way for all others, the outermost shell has 2 electrons only. Outermost will be s only. Either it is 2s, 3s, 4s, 5s or whatever it is, outermost will be s only. So outermost it has 2 electrons for the remaining noble gases. So if the outermost configuration is full, completely filled, it is considered to be the stable element. That is what they mean here as stability. Next, the name, our name, chapter name, chemical bonding. What is chemical bonding? What is a bond? A bond is formed by force of attraction between 2 atoms in an element. How is a bond formed? A bond is formed by combining or 2 atoms. As in, when 2 atoms react, when will an atom react? This atom of an element is somewhere else. So it has to, this particular atom who is in deficiency has to react with the this atom who is in deficiency is X atom, and it has to react with Y atom. This Y atom is somewhere else. Isn't it? The hungriness is for X atom. It has to pull the Y atom towards itself. So what has to be pulled? What is needed to pull the other atom? It's force of attraction. So X atom has to apply a force of attraction to pull the Y atom towards itself to satisfy its hunger of electrons. So that is what. So when it is reacting, when it is force of attraction, bringing the Y atom. It forms a mutual sharing of electrons and forms a bond between X and Y. That you call it as a chemical bond. So the force of attraction between two atoms in a molecule to attain its stability. So when it is forming a bond between two, it will attain its stability. So who is determining this bond formation? There are three methods to attain stable configuration or bond formation. Number one is transfer of only one or more electron from one atom to another. So just the transfer of one electron or more electrons from one atom to another. What type of bond is formed there? It will form ionic bond or electrovalent bond. It can be called as ionic bond or electrovalent bond. So let me tell about this ionic bond with an example. We have Al is aluminium, Cl is chloride. Ionic bond example is aluminium chloride. The formula for aluminium chloride is AlCl3. The valency of aluminium is 3 plus. Since it is a metal, it will get plus. Why is it getting plus? Let's see. Aluminium's atomic number is 13. Its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p1. See 1s2, 2s2, 2p6, 3s2, 3p1. If you see, this is the outermost shell for aluminium. This is your outermost shell for aluminium. Outermost shell, it has 3 electrons. Isn't it? If this is not there, assume, then this one is completely filled. So for this completely filled configuration, stable configuration, aluminium has to donate its extra 3 electrons. When it is donating, aluminium will get plus charge because it is doing good for the other atom. Okay. So it has to readily lose its 3 electrons. Next, coming to the chlorine. Here we have chlorine. Chloride, 3 molecules of chlorine atom is there. Chlorine's atomic number is 17 and its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. 3p5, if you see outermost, it has 7 electrons. So how many electrons it has to get to attain its stability? Only 1 electron it needs. But aluminium is ready to give 3 electrons. Chlorine needs 1 electron. So that is why aluminium is reacting with 3 molecules of or 3 atoms of chlorine. Chlorine, 3 atoms. So chlorine, see aluminium is reacting. I said no, aluminium has 3 extra electrons. So each electron of aluminium, it is donating to 1 atom of chlorine. Hope you all understood. It has 3 extra electrons. Aluminium has 3 extra electrons to attain its stable electronic configuration. So chlorine needs only 1 electron to attain its stability. So aluminium is reacting with 3 molecules of chlorine. Chlorine, chlorine and chlorine and forms a bond. What type of bond it is forming? Ionic bond. When will ionic bond form? Ions are nothing but charges. When does an atom get charged? When it is either losing an electron or gaining an electron. It gets charged. What charge it is? We have only 2 charge. Plus charge and minus charge. Plus you call it as aluminium will get plus. When is it getting plus? When it is donating an electron. When is it getting minus? When it is receiving or gaining an electron. So it is forming. When plus and minus charges are there, ions are being formed. It forms a ionic bond between aluminium and chlorine. Aluminium and chlorine. Yes, this is what is ionic bond. Number 1. First method to attain stable electronic configuration is atoms share 1 or more electrons from one atom to other atom to form ionic bond is your first method. Next, second type of bond is your covalent bond. Covalent. Co means joined, combined. 2 atoms combines its valency or joins its valency. What is valency? As I already told you, combining capacity of an element is called as its valency. When will an atom combines with other atom? When it has deficiency. What deficiency it has? It has deficiency of electrons, isn't it? So some atom will have excess electrons to attain its octet, and some atoms will have deficiency of electrons or less electrons to attain its octet. Such type of atoms combine, and its valencies are also combined to form a covalent bond. Let's see the definition. Sharing of 1, 2 or 3 pairs of electrons. It either loses or gains 1 electron, 2 electron or 3 pairs of electrons between 2 atoms to form a covalent bond. So to form a covalent bond, so either it shares or loses 1, 2 or 3 electrons, pairs of electrons to form a covalent bond is called as to form a bond called as covalent bond. Yes, let's see an example. Hydrogen and chlorine. Hydrogen atomic number is 1, that is it has 1 electron, which I denoted as X plus X, and then chlorine. Chlorine, it has 1, 2, 3, 4, 5, 6, 7 electrons in its outermost shell. Its electronic configuration is 17. So 7 electrons it has in its outermost valence shell. So it has 1 electron and it has 1 electron in its outermost shell. See, equally both it has to, what is that? It has 1 electron in excess and it needs 1 electron. So what happens? This both forms a bond here, mutual, a bond between hydrogen and chlorine. So it forms a mutual, this X of hydrogen electron and this dot of chlorine forms a bond. So the bond formed between by mutual sharing of single electron between hydrogen and chlorine is called as a covalent bond. Next, third type of bond is shared electron pair are contributed by, that is contributing, helping by one of the combining atoms to form a coordinate bond. This is covalent bond. What is it sharing? Valency. Whereas here, combining atoms to form a coordinate bond. Let's see an example. 2 molecules of hydrogen or 2 atoms of hydrogen is combining with 1 atom of oxygen. Isn't it? Hydrogen has only 1 excess electron. But oxygen needs 2 electrons. Oxygen is 2 minus, hydrogen is 1 plus. So, oxygen needs 2 electrons to attain its octet rule or to, to get that stable electronic configuration. So, this hydrogen, always I denote hydrogen with X just to show the difference. Oxygen, if you see outermost 2, this 2, and 2 here, 6. Oxygen atomic number is 6. It has 6 electrons. So 2 here, 2 here. These are bond paired. So these are in pair, but this one only is left alone. So this electron which is left alone forms a bond with hydrogen, 1 electron of hydrogen atom. So this pair, one single in a pair is being left alone, isn't it? So this forms a bond with another hydrogen atom. So this is called as coordinate bond. Oxygen is forming 2 bonds with the same atoms, or it can be same atom or it can be different atoms. So it forms 2 bonds, which you call it as a coordinate bond. Hope you all understood 3 types of bond atoms can form. One is electrovalent or ionic bond, number 2 is your covalent bond, and number 3 is your coordinate bond. Coming to the first bond, let's see 3 bonds in detail. Okay, the first bond is your electrovalent or ionic bond. Let's see the basic terms in that ionic bond. As I already told you, what is an ion? Ion is a charged particle. Charged. An atom, when will it behave as an ion? When it is getting that charge. When will it get the charge? When it is either losing an electron or gaining an electron. When it is losing electron, it is donating electron, it gets plus charge, which you call it as a cation. When it loses electron, it is called as cation. And it is a metallic atom. Which atom will lose electron, will have excess electron? All metals are capable of donating electrons. So all metals are called as cations. Example, calcium 2 plus, that is it has 2 electrons in excess. Sodium only 1 plus, that is it has only 1 electron in excess. Magnesium 2 plus, that is it has 2 electrons in excess. Then an atom which gains electron, gets electron, which borrows electrons from other atom are called as anion, and it gets minus charge, and is a non-metallic atom. Non-metals like oxygen, nitrogen, sulfur, phosphorus, all these are non-metals. Chlorine, bromine, iodine, fluorine, all these are non-metals. They always tries to borrow electrons from metals. Okay, so non-metallic atom. Few examples I have written. Oxygen is 2 minus, it needs 2 electrons. Chlorine is only 1 minus, that is it needs only 1 electron to attain its stable configuration. Nitrogen 3 minus, it needs 3 electrons. So an element which loses 1 electron to form a positive charge, and that element, if it is losing electron, you call it as an electropositive element, because it is getting plus charge. So all these are called as electropositive elements. When it is gaining electrons, they are called as electronegative elements. These are electropositive elements. These are called as electronegative elements. Next is conditions for the formation of ionic bond. What are the conditions, or what are the characteristics it should have to form an ionic bond? Number 1 is, we already discussed in our periodic table chapter, that is ionization potential. What is ionization potential? The tendency of either losing an electron or gaining an electron is ionization, or it forming an ions, polar compounds. Isn't it? The energy required to form a bond, or the energy required to either lose an electron or gain an electron, is called as ionization potential. So to form an ionic bond, ionization energy should be higher or lower. Let's see. To form an ionic bond, ionization energy should be very, very less. If ionization energy is very less, what ions are formed? Cations are formed easily. What is cation? Cations lose electrons. If it has more ionization energy, the energy required to form a bond, isn't it? So if it has more ionization energy, cations will not lose electrons easily. So if ionization energy is very, very less, the bond between them easily breaks. So cations, the bond in the cations easily breaks, and cations are formed easily. I mean to say, if ionization energy is very less, the bond between the atoms, the electrons in the atom easily is being lost, and the bond between them breaks easily. So cations are formed easily. Hope you all understood. Yes. The second point is high electron affinity. Affinity is attracting electron. So who will attract an electron? Who wants the electron in excess? Who is in need of electron? Who needs electron? And anions. So if electron affinity is very high only, anions are formed. Yes, anions needs electron. Isn't it? When is it getting minus? When it is getting electron, it has to get electron. Get electron means it has to attract electron. So that is what is your electron affinity. If electron affinity is higher, then anions are formed very easily. Third feature or third condition is large electronegative difference. So the electron negativity difference should be very, very large. One atom should have very high electronegativity and the other atom should have very less electronegativity. There should be gradual, so such a large difference between electronegativity. Then only they will form an ionic bond. If both are equally electronegative, then the bond between them will not be formed. So the atom which needs electron has high electronegativity and the atom which is ready to donate electron has very less electronegativity. So high electronegativity, less electronegativity. So the large electron difference forms an ionic bond between them. So more the difference, more the ionic nature of the compound and forms ionic bond. That is what are the three conditions for formation of an ionic bond. Number one is low ionization potential, that is ionization energy. And ionization energy is the energy required to either gain an electron or lose an electron is ionization potential. So that ionization potential has to be very low to form an ionic bond. So what type of cations are formed easily if ionization energy is very less. Then electron affinity should be very higher, then anions are formed. Then electronegativity difference between two atoms who is sharing electrons should be very large. Then it forms an ionic bond. Okay, next. Metals of group 1. We know in a periodic table, group 1 are called as alkali metals, group 2 is called as alkaline metals. I already told you in my previous videos about periodic table chapter. Group 1 is your alkali metal, group 2 is alkaline metal. So 1, 2 and 13th group, in between you have 3 to 12. Those are called as D block elements, transition elements, whereas 13th one, 1, 2 and 13 are metals completely. Metals of group 1, 2 and 13, they readily lose electrons, either 1, 2 or 3 depending on its valency, it loses electrons. Whereas non-metals of group 15, 16 and 17, yes, 15, 16 and 17 gains electrons. Yes, so which is considered to be the most electropositive? Elements of group 1. All elements of group 1 are considered to be most electropositive and all elements of group 17 are considered to be most electronegative. Note this point, group 1 is, contains the elements of most electropositive nature and group 17 elements are mostly electronegative elements. Then, why are ionic compounds stable? When it is forming an ionic bond, they form or they are called as ionic compounds. Why are they very stable? They are stable because the repulsive force between ions of like charges. If two, for example, two electronegative atoms are there, they both share minus charge. Electronegative is they carry minus charge. When two like charges are very close, repulsive force, like charges always repel. So there will be repulsive force of attraction between like charges. Then what type of force between opposite charges, unlike charges? It will have electrostatic force of attraction. Electrostatic, which means this is repulsive force, this is attractive force. Attractive force between whom? Unlike charges. Plus charge atom and minus charge atom will share the force of attraction. They both gets attracted, which you call it as electrostatic. Attraction between the electrons, electrostatic force of attraction makes them highly stable. Repulsive force makes it unstable and electrostatic force of attraction, that is forming an ionic bond, makes it highly stable. Okay, examples of ionic compounds. So in this chapter we will be discussing 3 examples of ionic compounds. Number 1 is sodium chloride, NaCl, and magnesium chloride, that is your MgCl2, and calcium oxide, that is CaO. sodium chloride NaCl, magnesium chloride that is MgCl2, and calcium oxide that is CaO. So each and every one in detail we will study. Sodium chloride, magnesium chloride and calcium chloride. I will be discussing these three examples under ionic compounds in detail. Next, the first example of ionic compound is sodium chloride. Let's see for sodium chloride. Sodium, if you see, the electronic configuration is 11, that is atomic number is 11. Electronic configuration is 1s2, 2s2, 2p6, 3s1. That is, it has one electron in its outermost shell. So it has to lose its one electron to attain the completely filled electronic configuration. If it loses this electron, the remaining all are completely filled configuration. So it has to lose this one electron. So it is getting Na plus. Since it is losing one electron, it is donating one electron, it gets Na plus. Then after giving one electron, sodium atom is becoming Na plus atom. So this Na plus atom lost electrons, isn't it? So it has, but electron only it lost. Protons will be as such like that. So it has 11 protons in nucleus and only 10 electrons in its 10 electrons in its outermost shell. So net positive charge is +1. So since it lost 1 electron, so net positive charge. Okay, that is about the sodium atom. So let's compare the properties between sodium atom and sodium ion. So coming to the sodium atom, its color is, sodium atom is white and its ion is colorless. Then chemical action of sodium atom, its chemical reactivity is very active. It's highly reactive because it has one unstable electron. So it has only one electron. So it always finds to bond, react with any other atom and lose its electron. That is why sodium atom is very active. But sodium ion lost this one electron. So completely filled configuration. It is reactive. It does not react with any other atom. Next, it's valence shell. Valence shell, if you see, the outermost is incomplete with one electron. Whereas for the ion, the valence shell is complete. See, for the ion, it loses this one electron. So it is, outermost shell is complete. Then electrical state, the atom is neutral atom. Protons and electrons are 11 each for sodium atom. But for ion, protons will be 11, but the electrons are 10 only. So it is positively charged. Since protons are more, protons charge is plus. So sodium is getting plus charge. Next, coming to the sodium chloride, we have seen what is sodium. Next, for chlorine. Chlorine electronic configuration is 17. 1s2, 2s2, 2p6, 3s2 and last outermost valence shell, it has 5 electrons in its p orbital. So it has to get one electron to attain its stable configuration. So that one electron, if it is getting, it will get Cl minus. So after accepting, it has to accept or gain one electron. The chlorine atom has one electron more than its number of protons. So protons will be 17 only. So when it is getting one electron, the outside electrons will be more, but protons will be 17 only. So electrons are more than protons. What is the charge of electrons? Minus. So thus chloride ion is getting minus charge. So the net negative charge is -1. Comparing the properties between chlorine atom and chloride ion. Coming to the property color. Color of chlorine atom is yellowish green color. Then chloride ion is becoming colorless. Next, chemical action. Chemical action, if you see, chlorine atom is very active because it needs one electron. So for getting one electron, so for receiving that one electron, it has to react with other atom. Then chloride ion is inactive because it is getting one electron and has completely filled configuration. So it is inactive. Then valence shell. Valence shell of chlorine atom is incomplete because it needs one electron. Whereas here chloride ion is complete. So it already got and is getting minus charge. Next, electrical state of chlorine atom is neutral. That is number of protons and number of electrons. Protons are 17, electrons are 17. They are electrically neutral. Whereas for the ion, chloride ion, electrons, one more electron is added. So electrons are 18 and protons are 17 only. So since electrons are more, the charge of electrons is minus, it gets negatively charged. The chloride is getting negatively charged, minus charge, chloride ion. So this is about the general properties comparison between sodium and chlorine. Next is the diagrammatic representation of sodium atom and chlorine atoms electron transfer. How they mutually transfer electrons among each other. Let's see in the form of diagram. See, this is your sodium atom where it has in the s orbital it has 2 electrons and in the next p orbital it has 8 electrons, so totally 10, and in the next s orbital it has 1 electron. So totally it has 2 electrons in its s orbital. Then in its second shell, first shell it has 2 and in the second shell 2s2, 2p6. So totally it has 8 electrons. Then in the third shell it has 1 electron, 3s1. 3s1. So this electron is unstable and it is left alone. Okay, this is unstable. So it has to lose its electron. Now let's see for chlorine atom. Chlorine atom, the electronic configuration is 17 we know. So 2 electrons in this first shell, 8 electrons in its second shell, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in its second shell and in the third shell if you see 1, 2, 3, 4, 5, 6, 7. 7 electrons. So it needs one more to attain its stability. So sodium has 1 extra and chlorine needs 1. So this extra electron is transferred to this shell. So here if you see sodium atom has to lose 1 electron. See this one extra. So it is becoming, when it is losing 1 electron, it is becoming Na plus. And thus it forms sodium ion. So Na plus, this 1 electron is lost here. So it forms 10 electrons. So stable electronic configuration and becomes sodium ion. Now coming to the chlorine. Chlorine needs 1 electron, excess. So 2, 8, 8 will become its stable electronic configuration. So it needs 1 electron. So when it is getting electron, it becomes Cl minus. So look at the diagram. After getting electron, that is 2 electron in the first shell, 8 electrons in the second shell and 8 electrons in the third shell. So totally 18 it is, chloride ion. Now it has become Cl minus, chloride ion. Now coming to the electron dot formula. Sodium, 1 electron in excess, and chlorine if you see 1 electron it needs. So this 1 electron is transferred here and forms Na plus and Cl minus. The ionic bond is formed between sodium and chlorine. Okay, hope you understood the first example of your ionic bond, sodium chloride. Let's see the second example, calcium oxide. The next example for ionic bond is calcium oxide. Calcium oxide. Let's see individually calcium and oxygen atom. See, calcium with its electronic configuration 20, that is atomic number 20, and electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. So till here 1s2, 2s2, 2p6 is 10 electrons. Here 3s2, 3p6 is 18 and 4s2, 2 electrons, that is 20 totally. Now number of valence electrons in the outermost shell is 2. So it has to lose those 2 electrons. So loses 2 electrons and forms, when it is losing or donating, it becomes Ca2 plus. So calcium is losing 2 electrons and forms Ca plus. Okay, Ca2 plus. Okay, now see Ca loses 2 electrons, minus 2 electrons and becomes Ca2 plus. So this is the diagrammatic representation of calcium. Calcium's electronic configuration 2, this 8 and this 8 and 2 electrons. Now this is the nucleus of calcium, 2 electrons, then 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Then next shell, 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. And in the last shell, 1 electron here, 1 electron here, which is like lone pair, lone, they are alone. Okay, that is X's. So this 2 electrons, so one from this side, one from this side, 2 electrons, it is ready to donate. And now it becomes Ca2 plus. Then look at the oxygen atom. Oxygen's atomic number is 6 and its electronic configuration is 1s2, 2s2, 2p2, 2p2. So it requires 2 more electrons to attain its stable electronic configuration. So it gets 2 electrons and forms O2 minus. Here it donates 2 electron and forms Ca2 plus. It gets 2 electron and forms O2 minus. So O gets 2 electrons and forms O2 minus. Oxygen electronic configuration before it is 2, 6. After getting 2 electrons it is becoming 2, 8 stable configuration. Now the diagram, if you see, the first shell has 2 and the next shell has 1, 2, 3, 4. 5, 6. 6. Okay, and now it needs 2 electrons. Okay, 2 electrons has to be filled here. So it becomes 2, 6. After getting 2 electrons, it becomes O2 minus. Now, so this Ca2 plus, after getting 2 electrons, it is becoming O2 minus, reacts and forms Ca2 plus O2 minus. 2 plus 2 minus gets cancelled and becomes CaO, calcium oxide. Okay, see, this is the electron dot structure. Calcium with excess 2 electrons, that is in its valence electrons are 2. And for oxygen, here 1, here 1. It needs 1 pair, that is 1 electron to make a pair. 1 electron here, 1 electron here. So it forms Ca2 plus. After losing 2 electrons, this is becoming 2 plus. After gaining 2 electrons, this is becoming 2 minus. So Ca2 plus, O2 minus, and forms calcium oxide. So this is the electron dot formula for calcium oxide. Now electropositive atom, electropositive, when it is donating, the particular element will become electropositive. Now calcium seems to be electropositive. So the electropositive atom readily undergoes oxidation, which means oxidation reaction means loss of electrons. Here, the electronegative atom, if it is getting minus charge, it is called as electronegative element. Now, oxygen being electronegative element undergoes reduction reaction. Reduction reaction, that is gain of electrons. Here, oxidation is loss of electrons. Here, reduction is gain of electrons. Electropositive element undergoes oxidation and electronegative element undergoes reduction by loss of electrons, by gain of electrons. So thus, this is the example for your ionic bond, the second example. First we have seen sodium chloride and second example we have seen calcium oxide for ionic bond formation. Yes, that's all for today's class, and hope you all understood the first type of bond. We have discussed what is bond, what is an electronegative atom, what is an electropositive atom, what are the 3 methods or 3 features for forming a bond, that we have seen, and 3 types of bond we have seen. We have seen an ionic bond, and we discussed about what is covalent bond. We discussed about what is coordinate bond. So in my next video, I will be covering completely about covalent bond and coordinate bond. With that, this chapter will get into an end. So, I think today's video, like all of you are clear with today's concepts of chemical bond and ionic bond formation. So, if you like my video, please help me by, don't forget to click like button. So, that's a great help you are doing for me. Yes, with your one like, YouTube will definitely suggest it to somebody. Yes, so your every like and every comment helps me a lot and motivates me for doing more such videos. So kindly don't forget to subscribe my channel. Please watch my videos after subscribing. That helps me a lot. Thank you.